Okay, so we're going to take a look at Anova. And Anova means analysis of variance. Okay, and that's the worst name that they could put in this because it's not an analysis of variance. Yay! It is an analysis of means. So maybe the acronym didn't work. Anoma, I don't know. Anoma looks good. Oh, that should be, it have to be means, right? Anomi, yeah, it doesn't look very good. So ANOVA is used to analyze the means, not variance. And it's when I have here, look at this table. Again, this table is very important for us. When I have a y variable that is a continuous variable, and my x variables are attribute, okay? And I can have multiples attribute variables there. So x is continuous, y is continuous, x is a categorical or an attribute. The purpose of that is to compare different means. Okay, so it is kind of the same logic of the two sample t-test, but you're doing multiple two sample t-tests, right? So remember, the two sample, you take compared groups, right, of things, like people that have glasses and don't have glasses, people that we kind of talk about kind of a bunch of different examples, right? So in our case, I told you guys about the Conti project, Capstone project case. We were looking at orders that were sent on a Monday versus orders that were sent on a Tuesday, for example. So I have two groups of orders, and then I can compare the means of those, right? In the class, we were looking at examples of new and old engine, right? Remember the emission of nitroglycerin sampling and comparing those groups, right? So we're going to do the same thing here, but it do that for multiple different samples at the same time, and give you the answer if one of those groups is different than the others, or if different than at least one of the others. So that's what it's doing. It's doing what we call a Tukey pairwise comparison test. This is similar to the two sample t-test. Remember here to look at some kind of outliers that you might have, but be careful to not delete everything that you think it's going to be weird, right? Especially on smaller data sets. But this is what it's doing here. You say to have a distribution here, and it's looking at the confidence interval and see if there is a difference there. So let's take a look at this example. And here I have 3 shifts. And the question is there a difference between those shifts, right? Is the mean different for this shift in terms of my level of defects, right? So data defects per 10,000 units produced and shipped for 1 month. Are all shifts produce the same level of defects, right? So that's our null hypothesis. And our alternative hypothesis is there any shift that has a different number of defects than any other one, right? So here we have a table with the data, shift 1, shift 2, shift 3. And here we have the histogram, and it's a 3D histogram just to make, again, more complicated. So sometimes I make it less complicated, sometimes I make it more, but it's difficult. It's difficult to. Are you seeing all the screens below? Oh, now we have Prime. Yeah, that's my Saturday morning. So here we have the 3 distributions, right? So do you think these distributions overlap? Do you think that there is a difference between those shifts? Yes or no? Think. So the histogram shows a little bit of distribution, but they basically overlap, right? You can see one distribution goes here, the red goes here, the green goes here. They kind of seem a little bit different in terms of shape, but they kind of overlap, right? So if they overlap, you're probably not going to see a difference between the shifts, right? And that's this case. So when you run Anova, and this is the results from Excel, Minitab, of course, do that. First, we're going to do one-way Anova, right? And it's important to differentiate that. So one-way Anova is when we have one categorical variable, okay? So we're testing one thing, which is the impact of shift into the Y variable, right? Into defects. You can have different categories within that categorical variable. We can have 10 different categories there, but it's still a one-way Anova, right? So let's say an example, the Conti project that we're talking about, orders can come any day of the week. So there's one category variable, which is day of the week, and I have 5 categories within that, right? That's okay. It's still a one-way Anova, right? When I'm looking at more than one thing at the same time, like days of the week and order size or something like that, so I have another way to look at that. Then is a two-way Anova, which we'll learn in the next class. Wait a little bit. I know you're very anxious to learn more and more about stats. So this is the answer that Excel does it. Data Analysis Toolpack has this capability. It is a single factor ANOVA. You have here the averages and the variances. So you can see the averages are kind of close together here, but there's still quite a bit of difference between shift 1 and shift 2. But the variants are high enough that the confidence intervals are big, so they overlap, right? So here you have the means, here you have the standard deviation, and here you have the confidence intervals. And you can see here that one is 45 to 67, right? That's shift 1, shift 2, and this shift 3. The other one is 40 to 66, so they overlap. The other one is 42 to 61, so they all overlap, right? But because they overlap, you know that there's no difference between them. How does ANOVA tells you that? By the p-value. So always keep your eyes on the p-value, 0.827, which is higher than our threshold of 0.05. So this value have to be less than 0.05 to reject the null, okay? That makes sense? So this is just showing our confidence intervals here, right? That they don't overlap. So they're, it's not significant. We cannot reject the null hypothesis. What about this here? Shift 1, shift 2, and shift 3. The same problem, defects, we have just different distribution. So is shift 1, 2, and 3 the same? Number of defects? So you can see here that the blue one, it's kind of in the middle. The green one is more on the lower bound, and the red one is more on the upper bound, right? So remember that these are 5 by 5. So we don't have, it's a big kind of chunk of data that we're going to put in the same bucket here, right? For this histogram. So there is show some difference here visually, right? The red and the green are probably the ones that are more farther away. So we need to take a look to see if the confidence intervals are going to overlap or not. But just looking at this histogram, comparing those two, you already kind of sense that, you know, red and green might not be the same, right? Are the ones that are going to have the higher difference. Run the one-way ANOVA, and this is what we get as a result. So can we say that there is a difference between the number of defects, the shift impacts the number of defects? Yes or no? Scream it very loud. Yes, it can. Because the p-value is lower than 0.05, right? So we can say that there's a difference, significant difference between number of defects when it comes to shift, right? And this is the confidence interval. It doesn't give you the confidence interval, and it doesn't tell you which one is different. So after doing Anova, you have to do 2 sample t-tests. Okay, so you know that they are, which ones are different, right? Or you have to create the confidence intervals, which also will tell you the same thing. So we can see here that shift 1 and shift 2, they don't overlap. Shift 1 and shift 3, they don't overlap. Shift 2 and shift 3, they don't overlap. So they're all different than each other. Okay, so practical, graphical, and analytical here to say yes, it is significance, right? Third shift is the lowest, second shift is the highest, first shift is somehow, some way in the middle. Okay, that makes sense? This is how to do it in Minitab. So, and you can also do in Excel, right? So here we have the step-by-step of how to do it in Minitab. We have a shift example here. It's, oh, no, this is not Minitab, this is Excel, what I'm talking about. So we have the step-by-step here, select the input range. So let's see if I have the example in Minitab for the one-way Anova, but we just have the, okay. So you take a look at input range. If you select the columns, you click here, where you want to go, where's the alpha that you're going to use, and this is the answer that it gives you. So pretty simple, pretty basic way, and it gives you the answer, not a lot of things to change. So what I want you guys to do now is to open your Excel file, and here you have, let's change this to share the Excel file. So in the Excel file, we have the different rules that were used to schedule production and measure the average lead time of different batches. So we have the rule of FIFO, first in, first out. So imagine that you're receiving orders of products, and each order is one batch, and you have to organize those into a production schedule to see which ones are going to produce first, right? You can use a FIFO, means what orders are received first is the one that I'm going to put first. The last in, first out, the last that I receive, I'm going to jump everything and put it first on the list. I can select the shortest processing time, so take a look at those batches and see which ones are the quickest ones. The quickest batches, the smaller time that will take, I'm going to put it first in the line, or I can do the longest processing time, say what are the longest batches, and then I put the longest batches first, right? And then I have this table with the average of the processing time of these kind of different observations, right? So I took 5 observations and of each rule, right? So I have 5 runs that I did. This is the one using FIFO. This is the one using LIFO, shortest processing time, longest processing time. So what I want you guys to do is to run the data analysis, to do the one-way, where is it? Okay, single factor Anova, which is the one-way Anova. Click here, blah, 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 as I explained, and let me know if you find out if there's a significance difference between those shifts, any one of those, yes or no. If I can reject the null hypothesis, yes or no. And if it is, which one is the shortest average time, and which one is the longest average time? Okay, so what is the difference between them? So when you finish this video, go there and do those tests, okay? And I will correct it in class.